All right, so section 10.5 is going to discuss solving polynomial inequalities, in particular quadratic inequalities and rational inequalities. This part of it is going to take care of polynomial inequalities. And the idea is to find the values of x for which this is true. This is greater than or equal to 0. Now, the way I suggest you solve this is by factoring it first. We got to figure out where this is actually equal to 0. That is 6x squared plus x minus 1 equals 0. And when this one factors, we should factor it. So I think this factors as 3x minus 1 and 2x plus 1. Now that gives us a couple places where this graph would cross the x-axis. So I got this times this equals 0. So that means either 3x minus 1 equals 0 or 2x plus 1 equals 0. And when we solve, I get x is 1/3 and x is negative 1/2. So if you're to look at the graph here of our parabola, this has to be the 1/3 and this has to be the 1/2. Now you can do that in Desmos as well. You don't necessarily need to be a pro here to be able to figure out what the graph looks like. So let's take a look at that. Now when you, let's see. Let me start all over with this one. When you get to Desmos, it's probably going to look like this. I'm going to type in f of x equals 6x. And then there's a couple ways you can get the squared key. One of them is from this keyboard. You can click the square there. If you needed to put in a cube or something like that, you pick this next one and it'll allow you to put in any variable you want, or any exponent you want. Plus x minus 1. Then you can see that this graph crosses at about 1/3 and negative 1/2. So it matches what we expected. To solve the problem, what we're interested in is finding out where this graph is greater than 0. That is, where it's above the x-axis. And it happens at a couple places. It happens to the left of 1/2, where the function's positive, and to the right of 1/3, where the function is again positive. In between, the function is negative. Now your solution to this is the values of x that make the graph something above the x-axis, make it positive. So I want everything to the left of 1/2 and everything to the right of 1/3. Those are going to be my solutions. Now, you have to write your solutions in interval notations. Now, in particular, let's see, well, let's do this part. It's going to be negative infinity to negative 1/2. That should be a negative 1/2 there. Can I actually use the endpoint of 1/2? Well, if I put in 1/2, I'd get a 0 here. And since 0 is greater than or equal to 0, I can use that point. I'll use the endpoint, so I'll use a bracket. Union, this next interval would be 1/3 to infinity. Infinity and negative infinity always get a parenthesis. This one again is going to get a bracket because I can use that 1/3. So there's my solution. Now you might look at that and go, well, can't I just get that from the graph? You're absolutely right. You could get that from the graph. But I am going to go a little bit farther with this and showing you how you can get this positive, negative, positive pattern without necessarily referring to the graph. And it's not because of these problems, it's because of problems we're going to do on Monday, which would be our rational inequalities. So a couple other things to say about this while we're here. Let me pause for a second though and see if you're okay with what we've got so far. We okay here? All right, so thumbs up there. That's good. Let me make a little change here. If my inequality was 6x squared plus x minus 1 is greater than 0, then I wouldn't use the endpoints. Then my solution would be negative infinity to negative 1/2, parenthesis, union 1/3 to infinity. So I can't use the endpoints. And one last variation on this one. If I had 6x squared plus x minus 1 is less than, we'll go less than 0. Then instead of wanting the positive intervals, I'm going to want the negative interval. So the negative interval is just that middle one in between here. So that'd be negative 1/2 to 1/3, like that. All right. Now, I asked you to graph this in Desmos for a particular reason. And you can do this on the graphing calculator too. It's just that not everyone has a graphing calculator. So everyone does have access to the internet. I want to show you a trick on how to figure this out in a different way without necessarily referring to the graph so much. We're going to draw ourselves a little number line here. And on that number line, I'm going to put some points. I'm going to put the x-intercepts, so negative 1/2 and 1/3. And the idea here is that I don't necessarily need to know exactly how big this is in terms of its graph. I just need to know where it's positive and where it's negative. So I'm going to test some points in between here. And just see where the values of x make their expression positive, negative, or positive. So we're going to look at that expression and test some values of x. So this is where I could use some help from you. I need some points, say to the left, or a point to the left of negative 1/2, a point between negative 1/2 and 1/3, and a point to the right of 1/3. So let's start here. What's a point that I could test to the left of negative 1/2?
Negative 1.
Negative 1, sure. Excellent. Someone else for a point between negative 1/2 and 1/3?
0.
0. Thank you. And someone else still to the right of 1/3?
1.
1. Beautiful. So those would be our test points. And let's go back over to here to this graph. Now, the nice thing of graphing this the way I did with f of x is that I've now defined a function, and I can do this. I can say, all right, hey, Desmos, tell me what happens when I plug in a negative 1 for f. So f of negative 1 gives me 4. Wow, that's cool. So the important part there is that by putting in a negative 1, I got something positive. Let's go to the next interval. Let's type in f of 0. Now, f of 0 gave me negative 1, but what do you think the important information is I get out of plugging in a 0? F of negative 1.
Positive?
Yeah, to see if it's negative or positive. In this case, it's negative. And the last one, we're going to do f of 1. And I got something positive. Now, it doesn't exactly matter what you choose. You can choose really crazy numbers. I could choose f of the square root of 3. And it's still telling me the same thing, right? I got something positive. My morning class chose f of 2. And again, I'm still getting something positive. That's all that really matters. No matter what point you choose to the right of 1/3, when you plug that in, the function is going to be positive at that point. And that's what we're interested in, is knowing where the function is positive or negative. Because for us, in our solution, we want the positive part. I want those two intervals. Now here's one other little bonus for us. Let's go back here. Can anyone tell me before I type it in, what's going to happen if I type in f of -1/2? What'll I get? 0, right? Oh yeah, because f of -1/2, that's the root. So -1/2 and 0. So the big question is, can I use the endpoint? Well, the way the problem was set up, you can, because f of -1/2 gave me 0, or excuse me, the function at -1/2 gave me 0. Is 0 greater than or equal to 0? Is that true?
Yes.
Yeah, it is. So when you're looking at this and saying, okay, my answer should be -∞ to -1/2, you realize, oh, I can use the endpoint. So I'll include that with a bracket. Union. I can also use 1/3. And again, the nice thing about Desmos is that you can just type that in. Here, let me just cheat here. I'll use this one again. Divided by 3, f of 1/3 is 0. Perfect. It's exactly what we're looking for. 0 is greater than or equal to 0. That's true. So I'll include the endpoint and go all the way out to infinity. Now, if you have a graphing calculator, you can do the same kind of testing of points on a graphing calculator. It looks a little different. I'll put a file in the chat. So let's see. So I'll put a file in the chat that shows you exactly what to do. And I'll kind of go over it here real quick. It works on the same example we just did. 6x squared plus x minus 1. The first thing you have to do with your graphing calculator is adjust the window setup. So here's the exact keystrokes you need to enter. That 2 here means you have to hit the down arrow twice. And what you're going to do is you're going to set the independent variable to ask and keep the dependent variable set at auto. Now let's take a look at what this would look like on the graphing calculator. So second table set, my table's already set up here, so I can clear. Let's see, I guess I can't clear that. I can do second quit to get out of this. I've already got the function entered, 6x squared plus x minus 1. To get my table, once I have this set up, you hit the second key, then the graph key. And then you can type in whatever values of x that you want. For our class, we chose -1, 0, and 1. My morning class, as I mentioned, chose other points. But guess what? It turns out to be the same thing. Positive, negative, positive. So here's ours, -1, 0, and 1. So it ends up being the same thing. Now, like I said, with parabolas, these are kind of predictable and the graphs are easy. You can kind of fake it without necessarily testing points. But in the second part of this stuff on Monday, when we do rational inequalities, the graphs are going to look a lot more bizarre, and it's not going to be as easy to do it by just looking at the graph. So I suggest that you get comfortable playing around with testing of points like we did here, so that you can decide where it's positive, where it's negative, and then put your solution in accordingly. Okay, so a lot there. Let me pause here, give you a chance to follow up with some things that might be on your mind still. If I went over something too fast, then now's your chance.
So I do have a question.
Go ahead,
And
please.
yep, it's in regards to the graph that you did originally for this -1/2 and +1/3. Just to make sure that I understood, are you saying that because from this graph, we should be able to take away that like everything to the left of -1/2 because it appears over the
Above the
the
x-axis.
x-axis? Okay, and the same with the 1/3. That's what this graph would tell us, right?
Yes, because
And then,
it's positive here because the graph is above the x-axis, so that makes it positive. Its y-coordinate is positive, and same thing here. Mhm.
okay,
Yes. Yeah.
all right. And then when you went on to go through the process of the test points on the number line, that's the same thing of that right here, this graph depiction. This is on the number line. You're showing us with the test points, right?
That's a nice summary of exactly what we did, and I really appreciate that. So these two things are showing you the same thing. The graph here is saying, oh, I'm positive here, and I'm also positive here. Now, without as much visual, we get the same information down here, positive, negative, positive, and we got that just by testing points. This is a more mechanical approach, and it's going to be easier for you when we do rational inequalities. And I keep on mentioning that. Let me give you an example of a rational inequality. It'd be something like g of x equals x minus 3 over x squared minus x minus 12, something like that. Okay, that's a rational inequality. Its graph is going to look pretty ugly compared to the graph of a nice parabola. But yet we're going to do essentially the same thing. We're going to find some points on the number line where this sign, the signs of this can change, and just test in between. It's going to make it very neat and concise, a very simple problem compared to what it could be if you're trying to graph this and deal with a graph. So great question. I really appreciate it. Anything else in terms of follow-up here? Something that's on your mind I can help with? All right, I'm going to stop things here, and good luck with the homework.